Hi, and welcome to this quick tool review. This time around, we'll take a look at some tubing bending tools, including a new one introduced by Vivor. So I have here some pretty basic tubing benders. This is a small diameter tubing version for something like 1/8 inch, 3/16 and 1/4 inch tubing. Although the design of this one is fairly pathetic. It works, but not particularly well. Here's some 1/4 inch plastic tubing that would be really easy, and you simply set the tubing in like so on the appropriate die. There's 3 different size dies on this, and then wrap it around the part, and you can see you can get a 90-degree bend right there. I'm using plastic just to show how easy it can be, or how they function. This is another size up, a slightly better built version, also aluminum. Both these are cast aluminum parts, but it looks like they took a little effort to machine flats here to make the text stand out. This one does 1/4, 5/16 and 3/8, works in a nearly identical manner to the smaller one. Pop the part there, take the die on top and run it around. So you notice this is a larger diameter 90 than this one, and I'm not quite sure how they arrived at what was possible. It's probably because this one is designed for larger tubing, so the radius of the 90 on this one is much larger because it has to deal with larger tubing. Clearly this is a much smaller diameter 90-degree bend on this guy right here. As you can see, it's like half. So that's an interesting observation. But all of these use a die and form channels to not flatten out or deform the tubing involved. These guys are good for soft copper and soft aluminum, as is this style right here. This is a spring bender, and with this guy, you stick the tubing inside and you just bend it, and while the inside of the spring pushes on the tubing, prevents it from buckling out, forming a non-round surface. Not made for plastic tubing though. In this box we have a tubing bender from Vevor. Set these guys aside, and this guy is capable of going up to 7/8 inch tubing, and it will deal with everything from soft copper and aluminum to brass, thin-walled steel, thin-walled stainless steel tubing. And by thin-walled, they're talking 1.2 millimeter or 50 thousandths thick walled thickness. So let's take a look at the product Vivor has sent us to evaluate here. For starters, it comes with a multi-tool manual, and it gives specs here. I've highlighted that it does soft copper, aluminum, brass, thin-walled steel, and stainless steel, as I mentioned. Wall thickness less than 1.2 millimeters, which is actually just under 50 thousandths, like 48 thousandths, but I'm sure that's about where it's at. It does 90-degree bends, and this design of this tool is ratcheting, unlike this style where the force just must be consistent. So if you're trying to do something like stainless steel, these probably won't work very well, or even thin-walled steel, because they're not made to handle that kind of force. These are just inexpensive cast aluminum benders, as you can see, especially for small diameter tubing like this one here. The manual is okay quality. It covers 2 different tools. This is not the tool I have, and this one is the tool I have. Trying to understand the instructions are a little bit challenging. The English is okay, but the description of the parts is a little confusing, although fortunately they do point out what the parts are on the tool itself to describe them, so that helps and makes this usable. The English is okay. Again, understand the explanations are only so-so, but let's actually take a look at the tool itself. As has become more and more common these days, especially with kits like ones from Vivor here, they don't just provide the tool for the process that they're helping you complete, but they include all the ancillary tools you'd need to do that process in the first place, which I find kind of nice. The only problem is none of them are super high quality, but all of them seem to work adequately. So for example, here's the tubing bender right here, but included is a pipe cutter with an internal chamfering tool and a spare cutting die right there, which I thought was a really nice addition for it. This is about the quality of what you expect to find at one of your local big box stores. It looks like hardened steel rollers here, hardened steel blade, and the rest is a cast part, but quality is okay. The internal deburring tool is okay. They have another type internal deburring tool right here, which is kind of interesting. Fits over the pipe and you rotate like this. It'll do inside and outside, all in one. That's an interesting thing to include in this kit, because there's also other options they provide. They also have this rotoburr here, which is like what we'd see as a common Noga tool, with one blade, removable, looks like standard blade. So you could buy a Noga replacement blade if you wanted for this. Looks like a decent quality blade though. This is an interesting thing, just sort of metal parts cast in place, and then the actual tool itself. This tool requires a bit of assembly before use. That way they can fit a much bigger tool in a much smaller case. This case is not very thick, so it makes it fairly portable. That's handy if you're this kind of thing, if you're like in a mobile platform like a truck and you need to carry tools. Obviously a more compact design helps you carry more tools, so that's convenient. So you have to assemble it in several stages. First stage is the crossbar holder, I believe. Their specific name for this is former holder. So the threads are a little gunked up on this guy. I don't know if it's the screw side. No, the screw side looks fine. So it looks like this guy might be the issue. Looks like they chrome plated this after they drilled the hole, and they plated, some of the plating got in the hole. So I'm going to chase this with a tap real quick and clean this out. Not ideal that you got to chase the threads of a new tool you just pick up. I've had that with other tools I've gotten in the past. I don't think it's something you'd ever find on a high quality tool, but you know, you'd have to pay the price for that. I think it's unfortunate they didn't catch this bit, especially since a lot of home gamers in the United States wouldn't have a metric chasing tap, so wouldn't be easy to do. All right, back to the assembly. Hopefully that'll make things a bit easier, because this wing nut was really struggling, and yes, that's all it needed, was to be chased. Okay, interesting, keyed, nice touch. Second piece is this guy, which goes on this side here. Then we have two different type crossbars depending on the pipe tubing diameter that you're dealing with. This is 3/4 and 7/8, 1/2 inch and 5/8. That's the big crossbar, I'm guessing. And a smaller crossbar, 3/8, 5/16, 1/4 inch right here, which would be the smallest diameter tubing. Same sort of chrome plating, although these look like they were better, like the chrome didn't get inside, but let's, the ultimate test will see how the holder reacts to it. Yeah, these thread on just fine. I just got an anomaly with a bit of chrome inside. Okay, so, oh, got that upside down. Congratulations. Supposed to be like that. Fortunately, their pictures do help a lot. Seems to me it still looks like it's designed to go down below. So if we took the smallest forming die, which is cast, oh, they're spring loaded. That's kind of cool. Oh, that's a nice fit. Oh, that's really well done. Okay, I didn't expect that. So they've got a little piece of spring steel inside to hold this in place. These are like aluminum chrome plated and cast, all the way up to the really big one. Spring steel loaded, holds in place. It seems to me that this part should actually be down. I'm kind of curious about that because that doesn't line up with this at all. I think it should be mounted the other direction. I had it right the first time. The drawing is for a universal piece that actually doesn't come with this kit. Oh, this one right here. So they showed this one on there. So so there are two that are up, but the two they were using were the ones facing down, because the ones facing up obviously won't engage that dive properly. So we put this in there, rotate this around to say 1/4 inch tubing. Once you've got the proper crossbar in place, either the small one or this big one that's dual-sided in place, and the proper die in place, You release the handle, and it ratchets forward to bend the tubing. Tubing goes in through here and is pressed up against the die and pressed around the die this way. Because this is a ratcheting design, you get a ton of leverage here for a very small amount of motion. So a large motion to a small motion gives you a mechanical advantage. And on top of that, the force, especially if you're dealing with stainless steel or steel tubing like 7/8, there's going to be a substantial amount of force trying to push that tubing back. The beauty is the ratcheting will just maintain the position and it'll hold it. So you can just work it all the way until you push the tubing to 90, which in this case is probably just a little past 90 because they got to account for spring back. And then to release, you just lift the handle up and bar slides right back and you can remove the tubing. Why don't we try this on some real tubing next? I bet you thought I was going to use some 1/4 inch soft copper to demo this tool, but instead I decided to put it through its paces and use not quite its largest size, but pretty close. This is 304 stainless, 50,000th wall, so pretty much right at max. We could try and deburr this guy. I'm kind of curious to see if this works here. This was freshly cut. Yeah, it doesn't work great on the stainless, but maybe this wasn't made for the stainless. I'm not sure. Stainless is a bit challenging. So I'm going to go clean up these ends, especially with this big burr here. Stuff's kind of nasty. Don't want to cut myself. Be right back. All right, so I've got 1/2 inch dies facing up on this bottom part. They're 1/2 and 5/8 or 16 millimeter, 12 or 16 millimeter. You can just set the tubing on here somewhat centered. I'm going to be curious. This is going to take a fair amount of force to bend, so let's just see what we've got here. Well, it is quite a bit of force to push this here. So when they're talking about the tool maxing out wall thickness, I think they're talking about hand strength required to do the bend, because this is pretty substantial. 1/2 inch stainless tubing, 50,000ths wall, which is absolute max for the tool. And maybe they're worried about the parts bending too. Wow, okay. I need to set this flat now. The tool does sit somewhat flat like this, so then you can use your body weight to force this. That might be a little more force than the tool would like to have, but it's going to be necessary for the 1/2 inch tubing. Let me just bring you right back. So the flat part of the tool sits flat on this chair here. I've got the tool inverted so I can see the tubing, and this way I can just lean down to do the bend because it's kind of the limit of my hand strength. Now, I don't have super strong hands by any stretch. I'd say we're at 90 there. That looks like it could go a little past 90, which makes sense. There it is. So to release the tool, you just pop this up. There we go. There was quite a bit of force on it, preloaded. Let's see, let's take a look at what we got. So this was a pretty hefty test on this tool, I think. 50,000ths wall is, I think, pushing it, especially for stainless tubing. It looks like it slipped a little during the process, but we got a very nice bend in there. There's only the tiniest bit of flattening right here. I can feel it, but you got to know there's going to be some of that. Yeah, you can tell the diameter is a little reduced here. It wasn't going to be perfect because in order to be perfect, you would actually have to stretch the metal a lot. In order to pull off a 90 on a perfect round, it would have to change the diameter of the tubing and have to get thinner on the inside, or thinner on the outside, thicker on the inside, because this is a smaller diameter than this, or smaller radius than this. So this material has to stretch, this material has to compress, this material wants to bow out, which it did slightly, but not a lot. It's actually a very nice looking bend. Just taking a look at how close I got. That's pretty darn close. That's actually a little over 90. We'd actually have to bend that back a little bit. So I'm pretty impressed because I didn't think it was actually going to pull this off, especially with the plastic guides here. I thought they'd break. They're riveted in place. This was a challenging bend because, like I said, this took enough force that I had to use my body weight to lean on it. It's nice that the tool was designed flat here so that it could sit on a flat surface and you could push down with the handle. I don't know if that was accidental or on purpose, but it worked out pretty well. All right, so taking a look at just the general construction, I like the way pretty much everywhere here they've got keyways, keyways for rigidity here, keyway here so that this guy sits in along a ledge so it can't rotate. They use fairly thick material. These feel like they're made out of steel. The dies themselves are plastic, and because they're riveted in place, if you want to replace it or make your own, you're going to have to drill this out and then somehow thread this or something else. I don't think that's going to be a reasonable option. The price of this kit is pretty darn reasonable. It's around 79 bucks. So you're not expecting a daily workhorse if you're working in the industry. If you do, I'd expect eventually to have problems with these plastic dies, because especially if you're doing stainless like this with thick walls, because that's going to put a lot of pressure on it. If you're doing simple things like copper, that's probably not going to be a problem. The ratcheting mechanism is pretty decent. For the largest, there's not enough mechanical advantage for the largest diameter pipes, I'm guessing. I didn't do 7/8 inch copper pipe, but if you did 7/8 aluminum 50 thousandths, I don't know if this tool would actually pull that off, even though it's within the range of their specs. That's 1/2 inch 50 thousandths wall, and I had to flip this over and push. I like the design where you can set this flat and just use your body weight. However, I don't know how long this would last if you did tons of that. It's pivoting just on the cast aluminum itself with the chrome plating on this pin here. I think that's okay. If you're doing a ton of these, like you're doing dozens of bends a day, this probably is not the tool for you. There's probably a better tool. As a matter of fact, there's probably a hydraulic tool, which sounds like it'd be an even better choice if you were doing a ton a day, because even smaller pipe, you know, 1/4 inch probably not going to be even hardly noticed, but you know, if you're doing like 1/2 inch copper pipe, that'd probably get kind of tiring doing it all day long. Bottom line is they seem to use adequate strength materials everywhere it's necessary. It's not going to be designed for, you know, years of use unless it's just infrequent. If it's a daily driver, then again, none of these inexpensive tools are for the daily driver or the professional that needs them every single day or needs extreme precision. All of those things should be left to the really high-end tools that are going to cost many times what this one cost. The list price on this guy is currently $74.99 on Amazon. I'll provide a link below if you want to go check it out. Bottom line is it's more than adequate for any bending I've ever done. So it's an excellent kit for me and the home gamer or the occasional user. So I'm kind of excited about that. I like the fact that they thought ahead and just didn't make one massive case for this to fit in. So you take these bits apart here and you can store it in a much smaller space. If I can remember how it goes back, there we go, how it goes back in. There we go. Got a catch for the ratcheting handle and all goes back in pretty nicely. There we go. Everything included. The tubing cutter, I didn't try the tubing cutter on the stainless. That might be really pushing it, to be honest. This kind of thing is, normally I see it with copper, but you know what? What the heck? Let's see what their inexpensive tubing cutter can do. Now that I've got a handle here. I think mentioning stainless steel was probably an afterthought for them to begin with. I don't think they intended you ever to do stainless steel in this guy, especially since most people wouldn't have access to it at home anyways. But it does pull it off, and it looks like the tubing cutter's cutting the stainless too as well. I am totally surprised at that, and without much effort. Holy cow, that worked great. Didn't damage the cutting wheel. Look at that cut. That is really nice, actually. Cut off just this tiny bit in here. That's really impressive. Okay, I am duly surprised. This is a pretty nice pipe tubing cutter, and it comes with a spare cutting wheel. Okay, I'm impressed. I think that's about it for my quick tool review. I think I give this one a thumbs up. It's not super high quality, but for 74 bucks, you're not expecting that. And it does a plenty good job on materials that you wouldn't expect it to be able to pull off, like stainless steel tubing, 50 thousandths thick here. Copper would be a breeze. I think there's some intelligent design decisions in here. One negative was that one of the threaded parts, there was, in this guy here, I had to chase the threads with a metric tap. You may not have that at home. So the threads look beautiful now, but there was a little bit of chrome from the plating process stuck in there, I'm guessing. Some metal particles did come out when I tapped it, and now it goes on great. Just be aware that that could be a problem, and you may have to go find yourself a metric tab. So thanks for watching. Hope you find it useful. Hope to see you next time.